Jackie. I am Leah Biagliatico, and welcome to Productions and Operations Management 101. Partners, have you ever managed your time or scheduled the things that you have to do for the whole day, for the whole week, or even for the whole semester? Isn't that so helpful and makes your task easier to do and you're like more comfortable to do it? Good to know that our topic is just so simple that we will be able to apply our daily lives. Right, Lourdes? Here at Leah, this chapter focuses on the time management, equipment, resources, and also production. Just like human beings, a firm or company needs to manage its time for it to be productive enough and to perform its tasks well. Making a schedule will be a great help not just for profit, but also for the convenience of the employees and management. So let us not prolong the agony, partner. We shall now be starting the show. So first of all, let us know what is scheduling. Scheduling is the establishing the timing of the use of equipment, facilities, and human activities in an organization. It means that firms must be able to properly allot time and schedule to each work, such as production, labor activities, or even the machinery usage, in order to be productive and also to save resources. Scheduling helps the company to fulfill the tasks that they ought to do. Next, benefit is that scheduling leads to increase of productivity. It has been said so many times in this report that effective scheduling will lead to productivity. Well, it doesn't need to explain that much, because it's self-explanatory and very much obvious. It every applies to our daily life. In scheduling, we have high-volume systems which consist of flow shop and flow cost systems. Flow systems, high-volume system which is standardized equipment and activities, while flow shop scheduling scheduled for high-volume flow systems. I'll show to you an example of scheduling jobs. So here, we have scheduling manufacturing operations. Now, how can we determine if there's a success in such system? We have 6 factors in determining such. First, process and product design. Here, cost and manufacturing are important as achieving a smooth flow through the system. Next, preventive maintenance. Keeping equipment in good operating order can minimize breakdowns that would disrupt the flow of work. Third, rapid repair and breakdown occurs. This can require specialists as well as stocks of critical spare parts. Fourth, optimal product mixes. Techniques such as linear programming can be used to determine optimal blends of inputs to achieve desired outputs at minimal cost. This is particularly true in the manufacture of fertilizers, animal feeds, and diet foods. And lastly, minimization of quality problems. If you have high standard volume system, of course, there is a quite mild system and this intermediate volume system. Its output falls between the standardized type of output of the high volume system and major order output of job shops. That's a high volume system. Intermediate volume systems typically produce standard output. If manufacturing is involved, the product may be for stock rather than for special order. However, the volume of output in such cases is not large enough to justify continuous production. Instead, it is more economical to process these items intermittently. Thus, intermediate volume work centers periodically shift from one job to another. In contrast to a job shop, the run sizes are relatively large. Examples of products made in these systems are included in canned fruits, baked goods, paint, and cosmetics. The 3 basic issues in the systems are the run size job, timing of jobs, and the sequence in which jobs should be processed. Sometimes the issue of run size can be determined by using a model such as the economic run size model. We will now go to scheduling and low volume systems. The character of low volume systems are considerably different from those of high and intermediate volume systems. Products are made to order and orders usually differ considerably in terms of processing requirements, materials needed, processing time, and processing sequence and setup. It is because of these circumstances Job shop scheduling is usually fairly complex. This is compounded by the possibility of establishing firm schedule prior to receiving the actual job order. Under low-volume system is loading. Loading refers to the assignment of jobs to processing centers. Loading decisions involve assigning a specific jobs to work centers and to various machines in the work centers. When making assignments, managers often seek an arrangement that will minimize processing and setup costs, minimize idle time among work centers, or minimize job completion time depending on the situation.
Visual aids called the Gantt charts are used for a variety of purposes related to loading and scheduling. They derive their name from Henry Gantt, who pioneered the use of charts for industrial scheduling in the early 90s. Gantt charts can be used in a number of different ways, two of which are illustrated in this figure, which shows scheduling classrooms for university rooms for a day. Well, basically, the purposes of the Gantt chart is used to organize and visually display the actual or intended use of resources in the time framework.
A load chart depicts the loading and idle time for a group of machines or a list of departments. Here, let me show to you an example. That chart indicated that Work Center 3 is completely loaded for the entire week. Center 4 will be available afternoon on Tuesdays, and the other two centers have idle time scattered throughout the week. This information can help a manager rework loading assignments to better utilize the centers. For instance, if all centers perform the same kind of work, the manager might want to free one center for a long job or rush order under loading. Under loading have infinite loading, forward scheduling, and backward scheduling, and schedule charts. Infinite loading assign jobs to work centers without regard to the capacity of the work center. As you can see in the diagram, this can lead to overloads in some time periods and underloads in others. The priority sequencing rules described in this chapter use infinite loading. One possible result of infinite loading is the formation of queues in some work centers. Finite loading projects actual job starting and stopping times at each work center, taking into account the capacities of each work and the processing times of jobs so that capacity is not exceeded. One output of infinite loading is a detailed production of hours each work center will operate. Underloads in others. The priority sequencing rules described in this report use infinite loading. With infinite loading, a manager may need to make some response to overload work centers. Among the possible response are shifting work to other periods or other centers, working overtime, or contracting out of a portion of the work. Note that the last two options in effect increase capacity to meet the workload. More to come after I have a short break. So we're back at Productions and Operations Management 101.
Let's now talk about the two approaches in scheduling, the backward scheduling and the forward scheduling. First, the forward scheduling. It means scheduling ahead from a point in time. And the backward scheduling means scheduling backward from a due date. Forward scheduling is used if the issue is how long it will take to complete the job. In backward scheduling would be used if the issue is when is the latest job that can be started and be completed by the due date. Forward scheduling enables the scheduler to determine the earliest possible completion time for each job, and thus the amount of lateness or the amount of slack can be determined. Slack can be determined that information can be combined with information from other jobs in setting up a schedule for a current job. We also have sequencing. Determine the orders in jobs at work center will be processed. It is the way to organize the processing of different jobs in the work center. Workstation, an area where one person works, usually with special equipment, on a specialist job. This may be a factory. If work centers are lightly loaded, and if jobs all require the same amount of processing time, sequencing presents no particular difficulty. However, for heavily loaded work centers, especially in situations where relatively lengthy jobs are involved, the order of processing can be very important in terms of cost associated with jobs waiting for processing. Priority rules are simple heuristics used to select the ordinary which the job will be processed. Some of the most common are, these rules are abbreviated by the way. First is the FCFS. It is first come, first served. Jobs are processed in the order in which they arrive at the machine or at work centers.